In Chapter 7, we'll be expanding on what we learned in the elections video and learning about how to estimate various different things using statistics. One of the most basic things that we learned back at the beginning of the semester was that we use statistics, information about a sample, to estimate parameters or information about a population. There are two kinds of estimates, and we learned about both of those when we were learning about elections before. First, there's a point estimate. This is what actually happened in your sample. Like if an election poller did an exit poll in one state and found that Trump got 54% of the people that responded to that poll, people might report that 54% of the people in that state supported Trump. It's just found by taking the number that said they voted for Trump divided by the total number in the sample. Much more important in statistics is an interval estimate. This gives a range of scores, from a small end to a high end. On your calculator, it'll be given as just two cutoff lines at the bottom and top, but in the real world, it's most often reported as a number plus or minus a margin of error. The actual parameter is pretty much always somewhere in that interval. It might be a little bit above what your point estimate was or a little bit below, but it's like saying when the actual votes are counted, the final results are going to be somewhere between those cutoffs we came up with. Just how big that interval is depends on how large of a sample you have and on how confident you want to be of the results. It should kind of make sense to you that the bigger your sample is, the smaller of an interval you need. You can zoom in closer on what the actual answer is if you ask a lot of people. Confidence, again, is basically how accurate or how right you are in your answers. If you want to be right all the time, you need to have a wider interval that's going to include more stuff. That idea of confidence really is important when we're doing estimations and statistics. What confidence is how certain you are that the actual parameter, like the actual mean or the actual percentage you're trying to estimate, is in the interval that you predict. If I say I'm 95% confident, there should be a 95% chance that the actual answer is somewhere in that interval. We pretty much always express confidence as a percentage. Most often the numbers you're given are either 90, 95, or 99% confident, although in books you may see examples that go as low as 80%, and sometimes in the real world they might even use 99.9. A good way to think about confidence is that it's basically the chance that your prediction is correct. Literally, confidence is the percent of the normal curve that extends out from whatever your point estimate is. So if you're 90% confident, you'd have 90% of the normal curve in the middle. If you were 95% confident, 95% of all the possibilities are going to be in that area. So if you want to be more confident, you have to move further out and include more of the normal curve in your answer. The variable for confidence is C, and we usually write it as a decimal. So like 95% confidence, we would usually write as C equals 0.95. We looked before at problems where we were estimating percentages, but it's much more common to estimate averages. And a typical problem might look something like this. It says you want to know the average number of students in a course at Iowa Lakes. You take a sample of 36 courses and find that the average is 14.7 students with a standard deviation of 4.9. Find a point estimate and an interval estimate with 95% confidence. Except that the problems in your book typically read longer than this, the idea of them is pretty much the same. They'll always give you the confidence level, and they'll give you the other information you need, which typically is the average, the standard deviation, and how many things you're looking at. Problem first said to find a point estimate, and that's literally given to you in the problem. It's just the average of our sample, which is 14.7. If you have a graphing calculator, the interval estimate is easy to find too. Just like we did when we were doing the percents, you want to first of all get into stat mode. You're going to select tests, and you want to choose Z interval from that tests menu. Everything in chapter 7 is something called interval, so you do want to make sure you go to Z interval, not Z test up at the top. Once you've chosen Z interval, it's going to ask you for the standard deviation, the mean, the number in the sample, and the confidence level. Those were all given in the problem, so we just enter the information that we know. Once you've got all the numbers in there, you hit calculate, and it gives you a results screen that looks like this. Basically, it's saying the actual average number of students in an Iowa Lakes class must be between about 13.1 and 16.3. Somewhere in that range is where the actual average should be. If you're asked to find an interval estimate, all you really need to do is copy down those parentheses at the top of your screen on the calculator. Sometimes, though, you might be asked to find the margin of error. And you can always do that by just taking the top number minus the mean from your sample. So here it would be 16.301 minus 14.7. That gives us a margin of error of 1.601. You can mostly ignore this screen. All it's doing is showing you what's going on inside your calculator when you do an interval estimate. The formula that's built in there is shown to you, and all your calculator does is find the margin of error and then add and subtract it onto the mean. Later on, we're going to look at a variation on this, which you can use to find the number you need in a sample. But for now, if you're asked to do an interval estimate, just use your calculator. There are many different kinds of interval estimates that you can do. If you thumb through the menu on your graphing calculator, you'll see a lot of things that have interval after them in that tests menu. We're going to focus in on 3 of these, one of which we actually already looked at before. What we just got done doing was what was called a Z interval. You use a Z interval when you want to estimate an average, a mean for the whole population, and typically we use it either when you have what in statistics we call a large sample, or when you know a lot about the population ahead of time, and we'll get into the specifics of that here in just a minute. So here's a typical problem that's a lot like the one we did about Iowa Lakes classes a minute ago. You want to find the average number of children and families in Kossuth County. You take a sample of 49 families and you find that the average is 2.3 children. We're also given that the standard deviation is 0.38 children, and the question asks us to find a point estimate and an interval estimate with 90% confidence. So what we want to find out is what would the average of all the families in Kossuth County be for the number of children that they have? This problem involved 49 families. And while that doesn't seem like a huge number, from the point of view of statistics, that is considered a large sample. It's large enough that we can use Z as our model. So just like I did a minute ago, we'll go to Stat, Tests, and then Z interval. Again, you got to make sure it's interval, not Z test. We enter the stuff that we know, the standard deviation, the mean, the number in the sample, that 49 I was just talking about, and the level of confidence. Once you got everything in there, you hit calculate. On the left, you can see all the stuff that you have to enter. And on the right is the results screen that you get. The problem asked us to find a point estimate and an interval estimate. The point estimate is just the line that says x bar equals 2.3, and again, that was really just given to you in the problem. The interval estimate, I can just copy the parentheses at the top, and I'm good to go. You're never wrong to copy all the decimal places that are there, but it would probably also be right to say it's between 2.2 and 2.4. This problem didn't ask for the margin of error, but sometimes it will. And again, I can find that by just taking the top number minus the mean, the point estimate in the middle there. You could also take the mean minus the low number and you'd get the same answer. Either way, it's going to be 0.0893. So now I'm going to give you guys a minute to enter some numbers in your calculator and see if you can come up with the answer. You want to know the average number of unpopped kernels per bag in a brand of popcorn. You take a sample of 40 bags and find an average of 23 unpopped kernels with a standard deviation of 5.8. Find an interval estimate with 99% confidence. Give you just a minute to get all of those numbers entered, and then we'll compare answers here. So on the left, you can see what got entered to begin with. And again, the standard deviation comes first. That sometimes goofs people up, but the standard deviation is 5.8, the average is 23, the number is 40, and the confidence level is 99%. All this problem asked us to do was find an interval estimate, so I can just copy those numbers from the parentheses and say, in reality, the number of unpopped kernels must be somewhere between about 20.6 and 25.4. Well, the problems we just did were both z intervals. And the idea of a z interval is that you have something that typically involves a large sample in statistics. Now, large isn't always what people think it is. Sometimes you hear the word large and people picture those 10,000 or 50,000 people they interviewed for election polls. But all you need to be considered a large sample in statistics is 30. As long as you have a number greater than or equal to 30, it's big enough to use a large sample. The reason for that is that z involves using the standard deviation of the population, but as long as you have 30, the standard deviation of the sample is almost the same thing. You want to remember that number 30. That's going to be important in a couple of places, but if you have 30 or more, you can use z. If you wanted to use z with a smaller sample, what you have to know is the standard deviation of the population. Sometimes we do know that, like we knew, for instance, that the standard deviation for IQ is always 15. But there's a lot of times you don't know that, and in order to use z, you either have a big sample or you've got to know that sigma, that standard deviation for the population. There are a lot of times that people want to use smaller samples. The big time that comes up is in the field of quality control. And in fact, the whole theory of how to work out statistics using small samples was originally developed for quality control in the beer industry. It was developed by a guy at the Guinness Brewery so that they could make better beer. The idea he developed is what's called the statistic T, and T works for very small samples. If you want to do a T interval, you still go to that Stat Tests menu on your calculator, but this time you just keep on hitting the down arrow after you've gone to Z interval and go down to where it says T interval. So here's a typical problem. It says a sample of 8 people shows that the average height is 67 inches with a standard deviation of 1.5 inches. Find a point estimate and an interval estimate for the average height with 99% confidence. If you look at this, it's a lot like the problems we just did for Z. The only real difference is this is a very small sample. We have just 8 people instead of like 40 or 49 like we did earlier. Again, you want to go to Stat, Tests, and then Z interval. Again, it is interval, not test. You put in that the mean was 67, the standard deviation is 1.5, the number was 8 people, and we had a confidence level of 99%. Do be careful when you enter stuff because it is a different order than it was asked for Z. You just want to make sure that you do put everything where it belongs. And again, you're just going to hit calculate to find the answer. The point estimate, of course, is 67 inches. The interval estimate is those parentheses at the top, 65.144 to 68.856. This question didn't specifically ask to find the margin of error, but if it did, again, you just subtract the top minus the middle, and so you'd get 1.856. Here's another problem. You might want to jot these numbers down or put them in the calculator as you're working along here. A sample of 6 20-ounce bottles of pop showed that 259 was the average number of calories. This must be regular pop rather than the diet pop I have to drink after my diabetes attack. The standard deviation was 34.7 calories. And what we're supposed to do is find a point estimate and an interval estimate for the average calories in 20-ounce bottles of pop with 95% confidence. Again, you can see all the stuff you have to enter over on the left. The point estimate is going to be 259, the calories we had in our sample. And the interval estimate means it would have to be between 222.58 and 295.42. Here's one more example with t-intervals. Joe wants to find the average number of runs his favorite baseball team scored per game. This year he's going to have to wait a while before baseball gets started. He watched 12 games, and he found that they scored an average of 6.3 runs with a standard deviation of 2.4 runs. Again, we'll give you just a minute to enter those numbers. Question says, use this to find an interval estimate with 85% confidence. Now, I will tell you, in the real world, nobody ever uses 85% confidence, but books can pick just about any number they want, and so you'll put that down for the C level. You can see this worked out, and on the right, we're saying that they must average somewhere between about 5.2 and 7.4 runs. So again, Z is for big samples, T is for small samples. Sometimes people remember that by remembering T stands for tiny. The other thing you can do with interval estimates is what we did with the election video. It's finding binomial estimates, which means estimating percents. When we estimate percents rather than averages, this is called a proportion estimate, and it is on your calculator called 1 prop z int. Now, we did several examples like this before, but here's one more. Tells you NBS takes a poll of 4,000 people to see whether they like what the president is doing in office. They find that 2,279 people support the president. You'll want to know those numbers, 4,000 and 2,279. And our question is, give a point and an interval estimate of the president's support with 95% confidence. Also find the margin of error. I personally think the proportion estimates are the easiest ones because all you have to do is how many had a characteristic out of how many total. The one way people screw this up is you've got to make sure the small number comes before the big number. X is the small number, N is the total. So 2279 out of 4,000, 95% confidence. And if you look over at the results screen, you can see an answer that's somewhere between like 55 and 58.5%. The problem did say find a point estimate and an interval estimate. What I said on the last screen, of course, was the interval estimate. The point estimate is just that p hat number that's in the middle, which here was about 57%. You can also always find that just by dividing like the number that supported the president over the total number of people they asked. Again, the interval estimate is just those numbers in the parentheses. And you can always find the margin of error by taking the top number minus the middle. So here 0.58509 minus 0.56975. When you work that out, it's about 0.015 or 1.5%.